Here's an example problem to which we can apply our relative velocity equation. A light plane attains an airspeed of 700 kilometers per hour. We'll discuss what this term airspeed means. The pilot sets out for a destination 1,200 kilometers to the north, but discovers that the plane must be headed 20 degrees east of north to fly there directly. If you need a reminder on what this wording means, east of north, have a look at this picture here. East of north would be somewhat in that direction. That's the heading of the plane. The plane arrives in 2 hours. What was the wind velocity? So the premise is that the plane is moving through the air, but the air itself is moving. And that moving air we call wind. So if we want the wind velocity, velocity is a vector, so we need to find the magnitude of the wind velocity and the direction of the wind velocity. We need to find both of those things. So let's analyze our scenario here piece by piece. The first bit I'd like to pick out is this information about our destination being 1,200 kilometers to the north and it taking 2 hours to get there. So here's a little compass. North is that direction. Let's say we start here and our destination is understood to be due north 1,200 kilometers away. Okay, so this is the actual path of the plane over the ground. We want it to fly there directly, so it's going due north and ends up right at its destination. So the first velocity I want to define is the velocity of the plane with respect to the ground. That's what our subscript PG means here, of the plane from the ground's point of view. And that is exactly what this distance, 1,200 kilometers, divided by that time, 2 hours, represents. So 600 kilometers per hour, that's the speed of the plane with respect to the ground. The plane actually covered that distance there in that amount of time. So we've identified the first of three related velocities here. Next, the information in that first sentence about airspeed of 700 kilometers per hour. Airspeed means the speed of the plane with respect to the air. So the speed of the plane from the air's point of view. That is our 700 kilometers per hour. So we're calling that VPA, speed of the plane from the point of view of the air. Some similar terms that you may see in other problems. If you see something described as walking speed, that means the speed of the person with respect to the surface that they're on. Speed of the person from the surface's point of view. And our surface could be something like a moving walkway that is itself moving. Or swimming speed means the speed of the swimming person with respect to the water they're moving through. So the speed of the person from the speed of our swimmer from the water's point of view. So these terms are similar to the term airspeed. And that's how you interpret them. Okay, so we've got that. And let's see, we'll come back to this idea of heading. Lastly, what we want to find, the wind velocity, that'll be our unknown, the unknown velocity of the air, the moving air, with respect to the ground. The speed of the air with respect to the ground. That's what's meant by the wind velocity here. So if you're on the ground measuring the movement of the air, this is the velocity you would be measuring. Okay, so we've got these three related quantities, and the relative velocity equation tells us how they're connected. So we set up the equation so that our subscripts match up. So the velocity of the plane with respect to the ground is equal to the velocity of the plane with respect to the air plus the velocity of the air with respect to the ground. And we set it up this way so that the A's on the inside subscripts match up. The outside subscripts match up. The P matches up with the G, and that agrees with over here. So P and G match up with P and G and A's on the inside. There's our relative velocity equation. So we're going to use that to solve this. And this is our unknown we're trying to solve for. Let's talk about directions a bit here. First of all, the velocity of the plane with respect to the ground. So this sort of thing, this will point in the direction the plane actually traveled over the ground. So it actually went due north from its starting point to its ending point. So VPG points due north. This is pointing due north. So I've got my little plane here. It actually moved due north. However, the velocity of the plane with respect to the air, that points in the direction of the nose of the direction the nose of the plane is pointed. This is also known as the heading of the plane, or sometimes the bearing if it's a ship moving through water. The heading or bearing, that's the direction the vehicle is actually pointed. The nose is pointed. And so we're told up here that the plane is actually headed 20 degrees east of north. Headed. That means the nose of the plane is pointed 20 degrees east of north. So in our picture here, although the plane actually ends up moving due north, that whole time its nose is pointed 20 degrees east of north. So the nose is pointed like that, and the plane itself actually moves like this. So what it's doing here is pointing its nose into the wind to try and counteract the effect of the wind, and ending up moving due north. So VPG, that points due north. That's the direction the plane actually goes. But VPA, that's pointed 20 degrees east north. That's the heading of the plane, the direction its nose is pointed. Okay, so we figured out the directions of these two vectors. Lastly, the velocity of the air with respect to the ground, that points in the direction of the wind, the direction the wind is actually blowing. I think that one's the most obvious. Okay, let's pause there.